Let's see. Not sure if live, but we will see. Not saying it is. Live controlling. No. Looks like we're going. All right. All right. That looks like we're going. All right. I still feel like that's a little loud in my ears. There we go. Welcome to the stream for all those that are here. It is good to see everyone, right? Hopefully, if you're in the US, you're watching this on demand because I know it's a little weird, but I am streaming on a US holiday. So happy Memorial Day to you and for all of those who have family members or those that are close to you that have given their lives for service to this country. We honor you, and that is why today is here, and we greatly appreciate that sacrifice. Today, however, for everyone else, we're talking about commissioning, and Ali Reza is already here, ready to go. It is great to see everyone that is already here. I'm going to go ahead and apologize for audio, video. Obviously, I'm not in the studio. I bet you it sounds like I'm in a tin can because, well, I'm kind of am. I'm in a massive MCC room that is, I'm going to get set up a little more comfortable because we're going to be hanging out for a little bit. But I'm in a massive MCC room, which is a motor control center room. And we've got quite a bit of stuff in here. We're going to be going through some of the videos, or some videos of this facility. I'm actually on site at, I'm going to turn this down a little bit because it seems like I'm peeking out with this mic because the microphone is on my chest. So hopefully it's not too bad. Trying to get all the audio levels. Thank you for being here, for everyone that is here. It has been an interesting week so far. Hopefully you have been having a good week. I mean, it's Monday, right? So cheers to Monster Energy caffeine on a Monday. But if you're not, this is your first time on stream, normally it's a little bit better made up, but my name is Jason Watts. I am a CEO and founder of a little automation company out of Alabama, which is in the southern United States. That company is called Alpha Industrial Technologies. So you'll hear me talking about Alpha. That's who I'm talking about. I'm talking about our integration company. We do more than just integration. We do light industrial equipment OEM design, and we do some software packages. So where I am today is actually at a fairly large, what we call greenfield, so brand new from the ground up, they leveled out the field and then built this building. We have a sponsor today. Who's the sponsor? Is it just me? I'm the sponsor. But oh yeah, no, it's Monster Energy Drink. I wish Monster would sponsor me. It would save me a lot of money. That would be worth it. That would just keep the stream going. But yeah, so at this facility, I've kind of like lost track. I think I counted up. I know I've used up almost an entire subnet for IP addresses for this system that we're going to be showing you today, and that's a lot. So we've probably got at least about 175 devices that are on this project, and this is a fertilizer facility in the Midwest. As you can see, it's some of the videos. You could probably figure out where it is if you're from the US or whatever, but just going to kind of keep the location. I'll make it to where you have to try to figure out where we are because this is under construction and a lot of people, and while it is secure, it's still a construction site and there's a lot of stuff that if people were to kind of come out here and whatever, it wouldn't necessarily be the safest thing. So, yeah, so I'm in the Midwest United States, which in to everyone else, it's not really West. The Midwest for me is kind of just like Central, but whatever. It's called the Midwest. But yeah, so this facility is one of the larger facilities. Actually, it's probably the largest that I have started up on my own. I have worked in some that are at least a number of motor circuits that are quite. Dude, that's awesome. Welcome to everyone that is here. Again, I probably expect to have a little less turnout today because my U.S. crowd is. Hey, look, it's my wife. My wife actually showed up on stream. Everyone in chat, say hey to Hua. That is actually my wife. Legit, no no cap for the Zoomers that are on here. uh, but yes, so she's probably going to be the only U.S. person on here. So the lesson for today is kind of commissioning 101. So one of the things about today in the U.S., I've said it a couple times, it's a holiday. So there's no one else on site here today. And so it's a great time for us to kind of talk about commissioning and talk about all of the things that are here on site. And just kind of might be a little bit shorter stream today, but I want to give you a little bit of my kind of experience in commissioning these types of systems. Like I said before, while this plant is the largest one that I have done personally, started up and been in charge of, I've been involved in some other systems that are a little bit bigger than this in terms of motor circuits out at the mines. If you are a subscriber, you've probably seen some of the videos of the past couple of weeks. I've been out at those mines, and so you'll see that those operations are quite ginormous. Like they're quite large, and so yeah. So we're going to get started today talking a little bit about commissioning, and so because on a project like this, you can easily get overwhelmed. I'm going to show you some videos here starting out, just to kind of get you an idea of how big this system is. This room is probably about, let me do the quick math. It's like 100, so it's like 30 meters, 40 meters long. Quite a decent sized room just for the motor control centers. And we'll show some like pictures here, or I'll show some videos of this motor control center here. But as you can see, this is one of, I think, 13 motor control panels that we built, and these were built by Alpha in Alabama. And so Alpha Industrial Technologies in Alabama. So we've done all of the motor control centers, and then we've got a couple of medium voltage distribution panels. And so we'll be kind of talking about just the process of going through and starting up everything from scratch and how to not get overwhelmed. So first thing I want to do is show you guys a couple of just, I'm gonna have to redo my video here. So I'm gonna show y'all some videos, of this facility. And while I'm talking about it, I was gonna get my little face. For some reason, the internal camera doesn't like swapping between everything. So I kind of have to move everything around and add everything in. So, hey, how y'all doing? So what we are kind of looking at here is as the product would be coming into this system, this is the outside. And so what this is, the product that is coming in is actually raw chicken manure, and what is coming out is industrial grade fertilizer. But it's 100% organic, but incredibly nutrient dense. But what comes in is raw chicken manure. So it's quite an interesting thing. So as you can see here, this is just one little portion of the facility, and I'll go ahead and start playing this video. as we kind of going through and slowly just kind of talk about the different pieces of equipment here. If you're not used to agriculture equipment, then this stuff just looks like a bunch of boxes and a bunch of just things. But I kind of walk through just to kind of get you the scale of how big some of this stuff is. So this is a drag conveyor that you're looking down and moving up what's called an elevator that moves material up and down. This door here will show you here in a second. It goes into the actual receiving area. But just in this one little area, we have a bag house, a raw storage, a raw material storage. That's what that silo is back behind there. This large elevator, another large elevator, because one of the things about product and material flow in an agricultural facility is that you're having to go up and down quite a bit. This plant is fairly spread out, kind of large, but even that, it still has to go up and go down. Anytime you have to store something, you have to put it in at the top and then let it flow down. And so that's what's going on here. So inside this big metal building back behind here, we're about to show you the actual receiving area and some of the equipment that's in here. But just in this one little area, you could see that you have 1, 2, 3, 4, 5, 6, 7, 8, probably 10 or so motors, probably at least 50 to 60 points of I/O just in this one little shot right here. So it could very easily get a little bit overwhelming. And I will say that just this area is kind of, so this would be in the 150 control box. This back behind me is just the receiving area. So this double panel behind me is one area that I'm going to be showing you here in a second that just holds that equipment. So let's move to the next little spot, which is the receiving area. And this is that metal building in the facility. So I'm going to pause for a second right here. As you can see, remember there was kind of that double topped area in that last video? Well, this is inside of that building. And we'll back it up just a little bit to show this little area here. Because this is in an area that during the winter, it gets completely iced over, completely snowed in. Every part of the, or I guess most of the operational facilities and where there are going to be people, it's all indoors. So amazing, top-notch facility that when it opens up, I'm sure I will kind of like brag on it because this is an amazingly cool facility. So this is where the actual trucks with the raw material will come in, and you can see that there's a large, you can't actually see it from here, but on this wall, there's the large doors that would allow the trucks to actually come in, and then they would be allowed to fully dump up their full dumps all the way up into this, and then dump into this kind of receiving area back here. Underneath this area is an actual pit and an auger. So you can't really see it in here, but there's an area back here that you're just dumping basically into the floor, and it falls down through the floor and comes into the system. You can also kind of like where I started out, there's kind of just a raw storage, like, hey, we kind of have an overflow. And so that's what this overflow is for. If you want to feed that back into the system, like with a loader, you can load it in right here at this hopper, and it will go down and get onto the conveyor. So again, this is an agriculture facility, and so it's all about process flow. And again, in here, you have some pretty decent size equipment, a lot of conveyors. Just real quick, we'll talk about this type of conveyor since it is kind of front and center right now. Oops, went too far. This blue conveyor is actually a drag conveyor. And so it has paddles that kind of scrape along and drag along the bottom to scrape material. And then it'll come all the way up and then dump out the outlet here. For this particular conveyor is for what's called the overs. This is a trowel. It sits and filters out all of this material and drops onto this little conveyor belt here, and it will eventually, so anything that doesn't fit through this screen will come out into this blue conveyor. Anything that falls through the screen, which is the product that we actually want to use, will get put into this drag conveyor and will proceed into all of that kind of storage area that I just showed you in the first video. So this piece of equipment is called a trommel. And then for a little bit further back, you have a actual belt conveyor, because at this point we don't know what the consistency, the quality of the material is. We're wanting to use belts as much as possible in order to kind of spread it out, because there is a very powerful magnet right here to pull out any metal. We do not want any metal in our system, so it's going to be trying to pull out as much as the metal as soon as it comes in. You'd be surprised how much metal, how many bolts, how many screws, how many hangers, like just all sorts of stuff is in chicken manure. What's up, OG? OG is one of our members here, and if you did not realize, today we're not going to be doing much on the in the realm of making programs or making logic. I will be showing the program and showing how to step through stuff, but if you are a member and we are working on like a function block, we come up with something, members get access at different levels to those programs and those data blocks, those things that we make on stream. The members get access. So you see OG has that little blue star there. That means that if we were to build a function block, he would have access to that, and that is available to members of different levels. So just a little plug there for the members. But getting back to this equipment, it doesn't seem like each piece of equipment in and of itself is very complicated, and it's really not. This conveyor has it has one motor that turns. Well, actually, this conveyor has two. It has one for the magnet and one for the actual conveyor itself. And then it just has a couple of bits of I/O on it. So you have a motion sensor, which tells whether or not the physical coupling is actually coupled together. Because if you notice, this little yellow guard here, it's actually showing the chain from the motor. So there's a little bit of a gear reduction in the motor and the drive for all of this equipment. So you can see back here, there's a motion sensor for all of this equipment, because the motor, that chain breaks, then we think the thing is running, but it's really not. So that's what's called a motion sensor. So each piece of equipment really just has a couple of outputs and then a couple of inputs and maybe a starter or a drive for the motor. But when you start adding up all of these, you get a very large room full of equipment. And so it can kind of get a little bit overwhelming. So that's pretty much for it for the receiving. And don't mean to rush too much going through this. This facility's kind of big. I know I've said it a couple of times, but I want to give y'all a little bit of scale of it. And so I'm trying to kind of blow through this stuff. So let's go to the next portion. Is we've kind of seen the raw storage. So let's actually look at where the actual bulk of the process is going into. So this equipment is on the inside of the main facility. And where you see, and I think I actually zoom in down here at some point. Yeah. So that silver conveyor that came underneath the trommel eventually goes into all of that receiving kind of storage area. And there's a conveyor that comes back from that storage area. It's actually off of that hopper and comes into this area right here. And so one thing about the process flow is if you directly couple everything together, then you're not going to be able to survive any sort of like problems. So like if for some reason a piece of equipment shuts down, you want to have enough buffer storage in your process in order to kind of ride through that outage. If something gets hung up and shuts down a thing, you've got a guy that comes and pulls something out, or it gets jammed up, you kind of clean it out. It takes 2 or 3 minutes. You want to have enough storage material in your system to be able to survive those couple of minutes. And so that's what these hoppers are. You fill up this hopper with material, and then these screw conveyors, which you can't really see them very well from here. And I'm trying to think if I have another one on that will talk about this, but this is a different type of conveyor. that feeds into this drying system. And I kind of ran through it backwards, but you can see out of the dryer goes into what are called cyclones, and this product material gets blown through this, and anything heavier will spin and eventually work its way down to the bottom of this and this conveyor. And so you will see there's another conveyor here on the bottom that's conveying this material out. This is what's called an airlock. It's really just kind of paddles that rotate like this and help the material to always be kind of feeding from one to the other. And that way that the pressure inside of this from all of this isn't getting blown through all of the rest of the system. What's up, Ignatius? I saw Ignatius come on, but I was kind of busy talking. So this next piece of equipment is what's called a bag house. It is an air treatment, and you can see a very large inlet here. So you're going to have a lot of air that's coming into this with a lot of dust in it. And inside this, there are a lot of bags, filters, and these bags will fill up and kind of filter out material out of the air. And that material, you'll have a back pulse, and it'll poof, and that material will fall down into here, and then hopefully be brought back into the system. So this is a bag house, and it is an air filter. Now, the last part that we see in this system is we have another drag conveyor that's on this bottom, and it's dragging everything and putting it into this thing here. One of the things about chicken manure is while we are drying it in the dryer, it has to be at a certain temperature for a certain amount of time, and we have to guarantee that. And so that's what this final piece of equipment here is. It's just to get the pathogen kill for all that E. coli and salmonella and all of those fecal bacteria that's in that wonderful raw product that we have. Everything gets killed here. So by the time that it comes out this conveyor here, you actually are pathogen free. So all of the E. coli, all of the salmonella, anything that's in this system has been killed once it's coming out of this. So you actually have a clean product. It's just as clean as if you baked it in an oven, because technically it kind of has been. So moving on, we have kind of the outside area, which is kind of crazy. So the conveyor that is going out that door, or going out from that tender blender, is so that goes up there. I'd have to look at the process flow, but this is, I think, this conveyor that's going here. And what this building is here is a hammer mill. So it's actually grinding up the product and separating everything out so that it is of a consistent product quality. Because remember, we've gone through a couple of different stages of sorting, but one thing that you want, because we're going to be pelleting this product, is the fact that you want a really consistent material. And we've had some problems in the past where we didn't put this hammer mill system in because we're like, oh, well, it's going to be fairly consistent. We'll be able to kind of like make it pass. And it just didn't quite work. And so this will take any feathers, feather mill, anything that's a little bit stronger. It'll grind it up into a consistent material, and then it will put it into the storage area, which these large bins are the actual ingredient storage. Because while the core product at this facility, I'll just go ahead and play this as I'm saying this, while the core product at this facility is 100% organic fertilizer, it can produce mixtures. So chicken litter is really high in nitrogen. If you're wanting more phosphorus or other materials, potash, those other materials, you have to actually mix it in. So if you go to Home Depot or your garden center, your shop or whatever, then you're going to be looking at the different ingredient mixtures. And so nitrogen is about the only thing that chicken manure has. And so really good for leafy plants, but not so good for hardy things like potatoes or things like that. That's all kind of agriculture stuff. But with this facility, they want to be able to produce any sort of fertilizer. And so they can mix in different ingredients here. So it's not even built yet, but kind of off to the right side where this crane is and where this elevator is there's going to be a large truck loadout. So a truck can come in with, say, potash, for example, and drop it into this facility, and this will receive those ingredients and it will put it up into the bin. And so that's kind of what's going on here. So ingredients here. So you can see these are pretty big. I mean, these are probably about, I think these are around 65, 70 feet tall, 80 feet, so 25 meters or so. And I kind of zoom in here. This is the truck loadout. So the final product, the pelleted product, will be stored. You can have a large, just raw pellet product storage here. There's also storage in here, in these bins, and then there's more storage, a lot more storage inside this incredibly large building that can all be dry storage, because this facility has to run 24/7, 365. So, well, let's say 24/7. They don't run 24 hours a day. I think they're planning on running like 10 or 12 hours a day. But chickens poop all day. And this is taking the poop from a egg laying, so egg production facilities around these Midwest, and they're shipping all their poop into this area and making a product out of waste that is actually going to be marketable. So instead of these chicken farmers having to essentially pay somebody to haul off of their stuff, they're actually going to go through and make money off of that waste stream. So when you're kind of like talking to your customers about like, hey, what is your waste product? How can we convert that into, like Lucid just said, money? And yes, my in-laws are like, what does it smell like there? And I'm like, it smells like money. Here, it's pretty good. It's pretty all right. The first facility that we did like this, I've told, it was not fun. Not fun at all, because they were actually storing the raw manure in the same barn where they were producing the kind of like drying everything. And whew, it was rough. It was rough. Hey baby. I mean, eggs. I mean, yeah, like eggs are protein, and I would hate for you to find out where eggs come from. We can talk about that when I get back, which by the way, that is, again, if you're just coming in on the stream, we have a special guest in chat today. It is my wife, and that's Huamua. There is my wife, my wonderful, beautiful, better half. She puts up with all of my crap, and actually, so well, yeah, I mean this type of crap, because it's literally chicken crap. Anyway, we'll get off of that. But you can see that this facility here is kind of the loadout. You can see I'm zooming in here on what's called a distributor. And I wanted to show you this because this is kind of a smaller one. You can see this elevator brings the product up, and then it drops it off here. And eventually there will be a pipe that comes down into this distributor. And inside this distributor, there's a little pipe that rotates around and comes out each individual hole or pipe there. And that makes it to where you can pick which of these bins it goes to. Now, we looked at this guy, right? Obviously, this is just as tall, but there's a lot more of it. I mean, I think it's 3 by 3, or maybe even more. No, it's 3 by 4. So there's 12 bins here. So up at the top, there's this elevator, and there's going to be an elevator on the side. These elevators aren't even finished. Like they actually have a lot more. Uh, they have a lot more structure that's going up. They just can't go up any higher because they don't have the support. Because they have to go up so high. They have this massive distributor, this cone that is going to be up above this facility here, and kind of distributing out all of that. So that little pipe rotates around. Again, each one of these little pieces of equipment isn't too complicated. So even a really big distributor only has one motor, and if it's a 12 position distributor, it's only 12 inputs. So it's detecting where it is. But when you add that into a massive system, this room is just filled up with the motor controls. All of the actual I/O, I have them in remote panels out in the facility. So they're in these little 24-inch panels that are distributed out. They have an 8200 remote I/O out in the plant. So each piece of equipment is very kind of simple, but as it adds up, it gets more and more and more. So, and it could get very overwhelming. So kind of talked ad nauseum about that. Now, so let's take and look at off the bottom of this feeder right here, this blue little funnel here. It is going to go into what's called a mixer. And so I'm going to show you, we're going to kind of walk through. So this is the mixer that you have what's called a batching system that selects out the different material, and it brings it into this hopper. And this hopper then blends up the material, and then it goes out and gets served into the rest of the process. So in this case, it is going to go to a post mixing grinding. And it's not quite in there yet, but it's going to be going back to that second grinding. So say hey to my little van. I had to use the little van instead of my big command center van because the mines definitely killed my big van, and it is getting repaired. So the electronics, I was charging my van at this specific place at the mines to where I had it set up, and then I hooked my charger up one day and it goes pop, and I go inside my van and it smells like magic smoke, and nothing worked. So gladly, or fortunately, that was on the last day that I was there, but my big van is in the shop getting all of the inverter and everything swapped out. So there's my little van, and that just kind of gives you the idea, and I wanted to show you the scale of this facility. And Lucid, I'll tell you specifically where this plant is off stream. So just, it's not completed yet, and it's probably got a few more, probably a month or so before it's fully completed. Once it's fully completed and once it's kind of up and running, I'll talk more about like the actual location, because it is a pretty cool place. But right now, there's a lot of stuff over there, and I hate for someone to get an idea of coming out and wanting to snoop around on someplace. And so, because there's a lot of stuff that could be really dangerous. But I'll tell you that in a text message later or something. So I'm going to show you this stuff, but just kind of the scale of this facility. All right. This is the control room. I'm going to zoom in on it here in a second. It's a little far away. And so needless to say, those little windows are kind of overlooking this process flow. And as you can see, quite the the large facility here. And so one of the things about this plant is it's going to have a very robust SCADA system. And I know that Siemens has a SCADA system. It's called WinCC. There's a couple of different versions of it, but I am not ashamed to say that Alpha is a gold certified ignition platform integrator. And one of the things that we use, because we use ignition, you could do so much with ignition so easily because of some of the integrations that it has with basically anything. And the pricing model for an ignition system, you could get unlimited tags, unlimited connections, and you can do some crazy stuff. And the total software package is around $25,000 for kind of everything. And most systems come in under $20,000 for that software. And if you've ever bought a large SCADA platform for like a large plant like this, you will know that that is an incredible deal. So if your plant has is looking at kind of doing these larger SCADA integrations, I would actually recommend Ignition. And if you are in the US, definitely hit us up for Ignition, and we could remotely set your system up and kind of get you going on it. One of the other owners, Brandon Hughes, he is amazing. He is an ignition wizard. The stuff he can do with ignition, it's just chef's kiss amazing. But there's my little plug for ignition. Back to all the Siemens stuff that pays most of the bills. So as you can see, this facility is really large, and I'm kind of this receiving area, we'll talk about it here in a little bit. This is the kind of storage area. So once you get the finished product, you get to either load it out on a truck or send it into these bagging areas. And there's a couple of different bagging lines. There's what's called super sacks, which are these really big, I guess it's like 1.5 meters by 1.5 meters bags. And so it holds multiple tons in these big bags. Or you can have little sacks that you see at Lowe's or Home Depot or Menards or wherever. Like those bags of fertilizer are also produced on this. But the rest of this building, as you can kind of see, it's really big, and it's going to be used for storage. So all of this facility, they want to run it again, like I said, 365 days a year. So they're going to be running this facility all the time. Well, you don't fertilize stuff all the time. You only fertilize at certain times during the year. And so they are going to store essentially 8 to 10 months of product in this facility at any given time, which is kind of crazy, kind of amazing. So that's why there's so much space here. You kind of, as I zoom in, you can see the scale of this room. That's, as you can tell, that is a 2-story office structure. So they have some storage and stuff up on top, but that is two full floors plus some. So really big place. So your product is ultimately going to be what's called pelleted. And if you are not familiar with what a pellet mill is, here is an amazing example of it. So just real quick, I'm going to pause real quick and show you one of our, what we call automation panels. This is where the field I/O comes into, and that's what this little box is. So you can see the little Alpha logo on this panel. It's got a little screen on it, a little basic panel, just so that you can pull up a couple of diagnostic stuff on these pellet mills. Now, what a pellet mill does, it takes product out of a hopper. Again, remember, you want what's called surge storage in the process. You have a screw conveyor that pulls the product out of this surge and then puts it into what is called a conditioner. It'll go through the conditioner and be fed into the pellet mill itself. And none of these pellet mills are open, but what is inside this is a disc. It's just a round disc that rotates. And there are normally 2 or 3 different rollers that roll on the inside of this disc. The product gets shoved into the front, like you can see here, into the center of the disc and gets squished out. and then there's blades on the outside of the ring that cut off the kind of, if you've ever played with Play-Doh and had a little Play-Doh factory and you're kind of like squishing it and it has like all the spaghetti that comes out, that's kind of the way that this ring type system works. It's pushing the product out this ring, and as the ring rotates, the product is getting cut off by these blades and falling down through the bottom and onto what I'll show you here in a second, a drag conveyor. Just to show you how much product this plant is going to be producing, each one of these pellet mills can do, I think it's 4 tons or maybe 3 tons, 3.5 tons an hour of product. So a lot of product coming out of each one of these. Actually, no. These are, yes. Yeah, these are like 3.5, 4 ton pellet mills. The one that the other one we had was like an 8. And so these might actually be even more than that, because this whole facility is kind of intended, and you'll see up to 30 tons an hour of pellets, which is kind of crazy. But again, the little automation panel, everything. So imagine doing this plant without these automation panels. Everything would have to be pulled back from this massive facility all the way back into the central room. There's no way you could get me to do a system like that. It would be a nightmare. So the goal of these little automation panels are to bring everything into a system to where your longest I/O run is going to be around 100 feet. And so 100 feet, or I guess I should say 100 feet, so 30 meters, 35 meters or something like that, of that's kind of the longest run I want a run of an I/O to be. That way, there's 2 reasons. That way, I can use 24 volts on my I/O. That way, the voltage drop across those cables is not very, it's negligible. And then that way, it makes for a safer system. If you have 24 volts DC, it's going to hurt, but it's probably not going to kill you. Whereas with 120 volt AC or 220 volt AC in other places, or 230, then yeah, you could get in trouble. What's up? We got another member in chat. What's up, Claude? Great to see you. We're talking all about chicken crap today. That's what this is. So, yeah, so the point of these automation panels is from this MCC room where I am, all you're doing is running out 120 volt power, 220 or 230 volt in everywhere else. You run your AC power to this panel. Inside this panel, there's a 24 volt power supply, an ET200 remote I/O rack. In some of these, there's heaters, but everything is just kind of there to connect up in that box, all of the I/O. So these pellet mills have a good bit of I/O, and these are Italian pellet mills. They're from a company called La Mecanica, and they are pretty sweet. They have some pretty cool features, but they're a little bit advanced just in terms of their features. So, for example, there's like a die remover. It's like a hydraulic die remover. You can see the little hydraulic pump right there. And so you need some way to turn and control that die pump. Well, here you go. It's right there at this facility. So you walk up to this plant here, and there's this little plant. Press a button on it, and you can actually see the person working on the equipment. You can see it getting pressed out. You're working right there, visibly. You can see it. So, yeah. Unfortunately, there are no synchronous motors behind me today. I'm telling you. I'm going to try to do it, but unfortunately, I don't have any 400 kW synchronous motors at anywhere that I'm just kind of hanging out. These are, I don't know if you can see them in one of these videos. These aren't synchronous though. These are, I think, 350, and you can see we have a bunch of these pellet mills all feeding into this system. And if you notice, there's actually space for 3 more on this platform. So in order to get up to their full production, there you go. That's a decent sized motor there. Yeah. But this kind of shows you kind of what I was talking about before. So this screw conveyor on the top feeds into this thing called a conditioner. That's what this motor is here. So these are 300 horsepower. So what is that? 250 kW? Whatever that is. And I'll give a shout out to a non-Siemens motor manufacturer, WEG, WG. Saw you guys at IPPE. If y'all are watching this, like, these are great motors for industrial applications, or I guess for agriculture applications as well. Like, this facility is fairly well maintained, but not all of them are as well maintained. But they have great inverter duty motors. WEG, check them out. They are, obviously, if you're in an industrial environment, there are probably higher spec motors, and WEG has the higher spec motors as well. But in heavier duty industrial environments, you might be looking at something like an IEEE 841 SD100, like from Siemens. These are right up there with this. So yeah, take your dinner and come back. I will be here. We'll be going for at least probably at least another hour or so. And so yeah, take it back. So Lucid, these are actually on VFDs, which that's one thing that a lot of pellet mills are normally on soft starters because of price. A lot of these agriculture facilities, the main driving is kind of this capital cost. Like, they don't have a lot of capital money going into these agriculture facilities. This one, not so much so. These guys really wanted to have a top quality, almost industrial facility instead of an agricultural style facility. And so these are on VFDs. Each one of these has their own Rittal TS8 panel with a 300 horsepower VFD in them, and kind of everything to run one of these little so all of the motors, all the control is all on this one, coming out of one panel. So that's why we have so many panels. We have 5 panels just for these pellet mills. And when they go to add on these additional pellet mills, when they want to expand production in the future, it'll just be a matter of reproducing that pellet mill control, dropping another one into the program, and then hooking it up and going. So yeah, so you can see these, I think these are 30 horsepower, 25 horsepower maybe, motors for these conditioners. A conditioner goes in, and some product you want to put kind of binding agents into it. You have different chemicals that you want to put into it. Mostly for this product, they will go through and really want to dial in the moisture content. So if they get the content a little dry, they may put in a little bit of moisture here in order so that in the pellet mill, that die gets really hot. And so it actually will kind of bake the material. And so you want to maybe put in a little bit of moisture right there at the die as you're coming in order to make sure that as it kind of bakes it out into a nice, wonderful chicken poop cake. Yep, we're making cake. It's wonderful. You should try some. If you're just joining in the stream, I haven't been plugging the likes and everything. Be sure that if you're on the stream now, hit that like button on the stream. We're going to be going for a little bit while longer. I'm about to finish up this kind of overview of the plant, and really start kind of going into the details of how to commission a gigantic system like this and not get overwhelmed. So if y'all hit that like button, get it out there, get more people to come in. And if we could get people to join into this community, they're going to benefit. Everyone's going to benefit. So yeah, help it out, support the channel, all of that stuff. And if you're not subscribed, y'all know what to do. Hit that subscribe button. Apparently YouTube, if I say, hey, hit the subscribe button lights up. Tell me in chat if it actually does that. I don't know. Like when I say, hey, like and subscribe, does the subscribe button light up? Let me know. So let's move. I think I have one more video. And yeah, so this is, oh, I didn't, before this. So underneath that platform with all of the pellet mills, there's this big drag conveyor. And all of the material gets dumped onto this conveyor and dumped into it gets dumped into the cooler. And I saw the little subscribe thing like work on Mr. Beast's channel. Maybe it's only if you have enough, if you're popular enough. Dang it, that's that's sad. Well, I feel like I've been lied to. YouTube, why would you lie to me like that? It's just, I feel so. Anyway, maybe it's only if you're not subscribed, because I know everybody in here is already subscribed, because that is one thing that most of the people that watch these videos actually are subscribed, and so I really appreciate that. So we're going through, and this big old box here is what is called a cooler. And when I say big old box, you hear the redneck come out, because I am a redneck coal miner. So this big old box is a cooler, and it dumps into the top, and hidden in between, behind, in this kind of like little gap area right there, are these blades. And so they fold over like this, and then will pop open and then shut. And so what this does is there's airflow that actually gets pulled through the product. So it pulls it in from the side, pulls it up through the product, and gets this cooler air from the outside and brings it up into here, because you just went through this pretty hot baking cycle with the dye. And so you want to cool it down, bring it down to the proper temperature in order to prevent condensation. Because if you have really hot material, you're going out into 0, -°C an environment, then it is going to condensate, and you're going to have a bad time, because we're trying to control moisture here. So that's what this is. It gives the time for all of these pellets to sit and have nice cool air get filtered through them and sucked out, and all of that heat kind of goes out and gone. And again, in this little area has a cool little thing. So it has like these little knife blades that will push up, let product out, it'll fall down, and then it'll cut it off. Then, so that's a cooler. And we'll kind of go through all of this, and I'll show you this next piece of equipment is what's called a screener, S-C-R-E-E-N, just like a screen. And in it, it's kind of like a little bit different version of that big trommel that we saw in the receiving area, but it kind of does the same thing, except it has different size holes. So this is actually automatically sorting the product. So each one of these tubes, you have what's called unders, or crumbles. So you'll have pieces that are small. They're not kind of the pellets that are, however, remember, in the pellet mill, it kind of gets squished out, and then that blade length is here. Well, it's cutting it off at a certain level, and so whatever that is getting cut off, that's how long your pellet is. Well, if it breaks, and it breaks into pieces, then it'll get into this area here. So you'll have unders, crumbles, and then your pellets, and then anything that's left over is an over, And so it goes all the way over and out. And you can see down in the bottom down here, you have, and my panel's kind of showing it up, but look at that, nice little logo. And if you notice I did a little bit of rebranding on the channel, and so you might notice the logo. So, but you can see you could sort out the different product here by selecting these different valves, and so you're moving product going to different areas, and you can see here that it kind of gets a little complicated as we go along. So you can send things out. We have multiple elevators, go into different directions, valves, moving product. Some go outside to the big storage facility or the truck loadout, or you can redirect going down to the bagging line. And so all of this is done from in the control room, and yeah, so it's all cool. So let's see, do I have any more videos? I don't. Oh, yeah, here. We'll look at the MVP room. So this is the kind of machine distribution panel. So in it, you have your 480 coming in, and then you have a main breaker, and then all of your sub breakers going out to my panels. I say my panels. I guess technically they are mine since this product doesn't start. And so these are the MVPs, and you can see I've already walked past a couple of them in this video, but you can see where this door is open. That's right here. And I'll show you here in a second some of these panels. So each one of these panels, so this is one of those pellet mill panels, and it has a 300 horsepower drive in it. And one of the things that you'll notice about this is you don't see any air conditioning on these panels. They are filtering fairly what I call open circuit filtering. So, and this is just an experience of mine. If you can keep your room fairly sealed, when I say fairly sealed, there's obviously different levels of how sealed it can be. With the Siemens drives, they are all coated circuit boards on the drives. All of the equipment is already coated. So it can handle a little bit of non-flammable dust as long as it's non-conductive. It can handle that sort of stuff. And all of this stuff is fairly just dirt. And so you have filters on each panel. You have filters, and it's pulling the air into these and putting the heat into the room. And then the room itself is getting rid of that heat. So you don't see it on here because this is on the exhaust end. They haven't put it in yet, but they have a fairly robust filter system for the room from the plant side. And then they have sealed doors that I think you can see. You can't see them here, but they have sealed doors that are here. So this kind of facility here is fairly well sealed. And so the air control is being heavily filtered coming in. And so we're putting the heat into the room and then just pulling with a big exhaust fan, pulling all of that heat out in a way. And so there's a lot of heat that's going to be in this room, but with the Siemens drives, they are rated for a much higher rated than what you see in a lot of just agriculture drives. And again, this is going back to me being from coal mining and steel mills. That's the way that you're going to see it. And with environments where there is metallic dust, you do not want to do this. You want to have a closed circuit sealed container. The problem is when you get into these really big drive systems, the amount, just put it this way, you will spend just as much on cooling than you will with the drive system. And then it may not even be able to cool. So the best way to design a cooling system for these big drive systems is using exhaust fans and filtering and designing the room to prevent the ingress of any sort of dust. And again, go back to it again. These are category, I can't remember which coating they are, but the regular coating, not the Cyplus Extreme, just the regular coating on these Siemens products are at what most manufacturers consider coated. So like an extra coating, that's what they are doing it. So that's why your Siemens drives, your ET200s, I have pictures of some of these drives operating and they are completely covered in dust and completely just like coated in it, from where they'll just leave the doors open and there's just dust going into them and just run all day and never stop. And it's because the drives, all the circuit boards on all of the electronics, Siemens electronics, are actually coated circuit boards to a higher level, or to the level that most manufacturers are their extra epoxy coating. So, little tidbit there. Let's finish up this video and then we're going to get into this. So again, different panels, and again, all of these are motor control panels. And so, yeah, so let's go and let's see if I'm going to have to redo this. I don't know what it is. Does anybody know why, will it reset? Yep, it did. Okay. I don't know why it does that. You have to like reset the internal camera on this stuff. But we're going to be going through a little bit of my tips and tricks on how to start up all this stuff. Now, I will say, kind of thinking about this, there are Siemens products are coated to that, but as I'm sitting here, there's always going to be a weak link, right? There's always going to be your weakest link. And while this, if I can point to it right there, that's a power supply from a company called Meanwell, and they are really good, honestly. I have not had any problems, knock on wood, with those power supplies. But I don't know the coating rating, so like the environmental coating. I have never used those in a panel to where I would actually need them to be coated. But I will say I have a picture that one picture of a drive completely coated in dust. It's got one of these Meanwell power supplies in it. So pretty good, and they are fairly inexpensive because they are made in Taiwan. And yeah, politically, I say Taiwan because that's where they're made from. But so let's go through and let's get TIA Portal going. And I haven't even opened up my project yet, but I want to talk to y'all a little bit about how to get started on a system like this. And I guess I can kind of just get going with, yeah, take a break for a minute. Sponsored by caffeine. First thing I want to, sorry about the camera. I had to get through all of this. Let's see. So what I wanted to show you guys is I want to talk to you a little bit about just kind of tips on how to really get started. And what I was grabbing is, first thing I want to talk about is what you need to have in order to have a good experience starting up equipment like this, because frankly, the smallest things make the biggest difference. One of the things that I'll show you is I'll show you my little setup. And so like motion is going to be weird for a little bit. So but I'm going to show you my little setup here, okay? Hopefully nothing's going to crash. Actually, I don't want to move it. So, because I think my cable may come undone here. No, we're gonna risk it. If the stream drops, I will be back. Y'all be back, but I'm going to show you my little setup. So, what I have here is table, chair, okay? So, nice little chair here, comfortable. I have a card table that I'm using. If you are going to be doing these sorts of startups, invest in a good chair, a good table that you can fold up, you could take with you, you could go in and out, because that is going to be the biggest thing on one of these big startups is how comfortable you are. I have done way too many startups. I have been working way too many, sitting on like a spool of wire, sitting on like the table, and then have my laptop like crunched up, and I'm like sitting like this right here, working on it. You can only do that for so far, and for so long. And sure, you can have like the things, like the little tables that come on these, and you can just like magnet onto them. But then I just say, bring a table, bring a chair, have it set up, and you have no idea how much that is. Another thing, a little tip, is go ahead and order off of Amazon a bunch of patch cables, so like Ethernet cables. So order a pack of 10. If you can, just have a bunch of these. I have piles of these in my van, and it's because you'll get here and you're like, wait, I need to connect up these weird things because I don't have a connection between, all right, this panel and that panel, but it's connected to the one across, and so you have to kind of jump between them. On the initial startup, the biggest thing you're trying to do is get things communicating, getting the green lights. I'll kind of push this up a little bit. You can see that on here, this switch is all happy. I don't know if y'all can really see that, but that is your number one goal in a startup. The first thing you want is to get as many of your devices with green lights. Get everything set up with your program. Obviously, you've been working on the program for hopefully quite some time. You have set up everything ahead of time. You were coming in and you were just putting into that. So that's your first goal, is to get all green lights. But you can't get ahead of yourself. A lot of times you're coming into a project, and if you're not there early, you are going to be so far behind. Especially the worst thing you can do as a commissioning engineer on a project is wait until after everyone's done in order to plan your startup. If you want to make a customer unhappy, that is the quickest way to do it. You do not want to be the last one on site. And because everybody's like, oh, well, I can't do this because this isn't hooked up. Well, there needs to be an order that you are working with your electricians. And so fortunately, we were able to work with the electricians here and establish a protocol that the first thing that they need to be running is get power to each of the panels out in the field and out in this room. Get power run to all of them. That is number one. Second is Ethernet. So get the network connected up. Everything else, you can go from there. Focus primarily on power and communication. Because what will happen is your electricians will start, like those pellet mills. Those pellet mills have a ton of I/O on them, right? And they are working hours and hours and hours, weeks on getting all of the I/O hooked up to that. But they don't bring power to the panel. So you are waiting weeks and weeks and weeks to be able to check out anything on that panel. And oh, guess what? They finally bring power to it, but they haven't run Ethernet to the MCC room. They haven't done that. So your PLC can't even communicate to your panel itself because they haven't connected up these things. So it's kind of maddening at first of like, it makes you just like, well, I need to wait until everything's connected up. No, you cannot do that. You have to get out there and get some green lights. So for me, I've got enough of these green lights on to where I can actually do quite a bit of work. And so, but the first thing you're going to come out to is if you get power connected up to the systems, it's kind of like a stage, because a lot of times if you're still working on the power, they can't turn on an NDP. They can't turn on one of those panels because, oh, hey, we're still working on this over here. So work with your electricians to say the number one priority is get everything power associated out of those MDP panels, get it connected up. Get every bit of power connected up and everything to where you can start turning on things in these panels. You don't want to turn it on yet, but we're getting there. So the first thing that before they actually engage power from the NDP, any electrician should be working with they should do checks to make sure that nothing is short-circuited, nothing is dead shorted to ground, and those sorts of checks. And so you want to have all of your circuit breakers off before you throw that main load. And so what you'll do is you'll kind of step through the process of saying, okay, I want to power up my NDP with no loads. So I'm going to put power on it, but it's not going to have any loads on it. So disconnect all of those breakers. And you're just going to power up your NDP. That makes sure, and that's after you've gone through with your meter and checked all of the phases to each other and then all of the phases to ground. And so you want to make sure, all right, before throwing the switch into the NDP from like out at the medium voltage, you want to make sure that nothing's grounded, nothing's short-circuited. So I think, so we're going to do this. So now, once you've done that, you can start going through and testing. So nothing's shorted off in your system for what's it called, the MDP. So you're free to power up that now. Now at that point, you're wanting to come into your panels before putting the feeder breaker and putting power on the panel. You want to check inside your panel whether or not there is any of the incoming leads, which are going to be up on the breaker up somewhere in this area, up there, okay? The main breaker in each one of these panels, you want to check before sending power from the NDP. You want to make sure that there's no shorts, no grounds, nothing on incoming coming in, okay? So before doing any of that, you can go ahead and do those short circuit checks on the actual panel itself. You should have already done that. You should have already done that in production when you've done your point-to-point check. You should always check in your panels short circuits between phase to phase and shorts from phase to ground. So your panel should already be checked out, but don't take anything for granted. Don't take anything for the fact that, like, hey, it's been checked. You check it yourself before you throw it on, because this panel here, to replace the stuff in this panel would be quite expensive. And sure, you may not have to pay for it. I would, because technically until the customer buys this, it's my panel. So I don't want to blow anything up. So I have the perspective of, hey, this is my money until the customer pays me for it. So that's kind of the kind of thought process that you need to have when starting one of these things up. So after that, once you were going through and checking each individual circuits, you notice there's a lot of stuff in here, right? There's a lot of stuff. And one of the things that I cannot recommend enough is getting a good set of gloves. I know in a lot of different regions and different countries, leather is not okay. Find you some sort of insulated gloves that you can wear while working on these panels, because especially when you are kind of just going through and starting up. If you notice, I have like a lot of motor starters. I'm blocking my head. These motor starters here, they're all off, right? Well, the first time I go through and start those up, I'm going to be wearing these gloves. And you notice I'm not wearing my chain, I'm not wearing my ring, my watch that I normally do, my bracelets. And this is why, because it is very much safety of, you don't want anything to like accidentally either be hot, be electrically hot. You want to just make sure minimum this. Now, I'm not wearing sleeves right now. If we were starting up for the first time, like drives and things, I'll show you, you should, and with Siemens drives, they rarely explode on startup, on the first time you put power on them. It is a very, very rare occurrence that happens. And I'll tell you why it'll happen here in a little bit. But never take for granted the fact that something in here, when you put power on it the first time, isn't going to pop and arc flash. Okay? And so if the minimum, if I'm going to be changing something, I'm going to be using some sort of insulated gloves. Leather gloves in the U.S., absolutely. I mean, I love these things. They're comfortable. They are of good quality, and so they flex. They are good, and so I can easily move all this stuff. And so wear your gloves. So the larger drives are still 480 volt drives. So they are medium or low voltage drives. And Lucid's asking if they're the 4160, 4180 medium voltage drives. Most of the time, because of kind of the regulations involved in working with 40 medium voltage centers and 480 in your plant, it's very much different. So that NDP can absolutely still arc flash, and there are still arc flash requirements for things, but the amount of energy that is stored in the arc flash down there on a 480 system is much less than with a 4160 or 4180 medium voltage system. So it's a little bit safer to have those lower voltages inside the plant. Now, it's a 12470 feed line, and there's medium voltage transformers sitting right outside this building, and then there's medium voltage switchgear out there that is switching that out there. Having the higher voltages in your plant, it's one of those things to where a lot of people don't, especially at these smaller facilities where these are only 300 horsepower drives. If these were 3,000 horsepower drives, then you'd probably see it. I have a facility in the south that we're quoting now that actually has it's 1,200 horsepower drives on pellet mills, and there's I think 4 of them. And so for those, they're looking at medium voltage, because for that much power, you really want to keep your currents as low as possible. And because your losses, your power losses, are I squared R. So you want to keep your current as low as possible for your power losses. And that's why you would want to go for a 4160. For this place, though, they can't justify the additional regulations and danger for the higher voltages. It's just not really justifiable here. So get you some good gloves, and always have them. Always have them on you. I have these, are kind of my normal one. I don't know. I love the smell of leather, and I know, again, I respect other people that don't appreciate, or I guess maybe appreciate leather more than I do. But always have your good safety equipment, good gloves, and when you're starting stuff up, again, I can't say it enough. Never take for granted the fact that something isn't shorted out. And so just kind of be ready. And for me, there's a lot of times where you'll be taking, and even if most of the stuff behind me is, most of the wiring is 24 volts. But there may be, sorry, I'm getting my power plug back in. There might be something to where I am, say for example, there's a little breaker, and I don't think you can actually see it here, but there's a little breaker right next to it's right there. So it's right there. That little breaker is a single pole breaker for the 24 volts, and that powers up this whole rack over here. Well, I go to push that. All of that's 24 volts, but the terminals on that power supply, that's a three-phase power supply. So the terminals on that power supply, just right there, are actually 480 volts. So not only is it not 120, it's 480. And so you can see in our panels that we build, we always make sure to have color-coded wiring. So if you see blue, that's going to be 24 volts. If you see black, that's 480. If you see red, that is going to be 120 or 220. That's going to be the medium panel voltages. So you can see here, there's black wires over here, and so your colored phase leads in this panel are going to be 480. So if you see these colored phases, that's the electricians are wiring into this panel. You can see all of these here, but you can immediately see, just because of sticking with your color coding, I can immediately have an idea of what my danger levels are. And to trip that breaker, or to turn it on the first time, to turn on that little 24 volt breaker, in my mind I might say, oh, it's just 24 volts, so it's not really that much danger. But when I stick my hand up there, I realize, oh my goodness, there's a black wire right there. What the crap? That's 480. It's right there. And so that's why you wear the gloves, because there could be something there. That wire could come off, get on you, whatever. You don't know, especially when you're first going into a panel. And so, and also, like to the right of that, there's a little MD or MSP right here. I'm trying to look at the screen, but right here you have an MSP that it's a three-phase. So you turn that switch, and that actually turns on this power supply. And so that that device right there is a 480 volt device. This is a block. While it's touch safe, everything is done right, you still want to have gloves just in case you're flipping a breaker. You may not think about it, but these things can kind of get a little tight. So definitely have gloves. If you're starting up like the drives and all of this stuff as well, it's because you can kind of see right behind my head. This is a 250 horsepower drive, I think. It's a fan, I believe. And so I think it's a 200 horsepower drive. So this is actually a pretty big system in this thing here. But just so you know, and so you can see over here on this side here. Now these are all outputs, but you can see, I don't know if you can actually see, but all of these wires here are black, and then you have the colored phase voltages going out to the field. So in these mixed voltages panels, you can follow zone principles, which 24 volts for the most part up here, but these ET200 starters, they have three-phase outputs coming along here, along the bottom. So even with proper zoning principles, there's always going to be something. So get you a good set of gloves so you can be safe in that. Also, always have a couple of screwdrivers the proper size screwdrivers. Have you a screwdriver kit, a roll of screwdrivers that are kind of the electronics grade. Of course, you know, me being the German German equipment supplier, the lover of self, I'm going to have German branded or German tools. But get you some screwdrivers so this is Phillips head for kind of turning terminals, Phillips head, and then this is a size for the kind of like Ethernet cables and all of that sort of stuff. So now that you have power established to each of your panels, you're going to start trying to get communication. Well, the thing about it is, as you're going through these panels, your electricians are going to be kind of hopefully trying to address one panel at a time. And they're going to be going through, and instead of trying to do all 5 panels and working little things on 5 of the panels, hopefully you have a set of electricians that are trying to wire up all the motors, because you do not want to have that panel powered up while they are wiring things. So the next step is, once you have the ability to get power on, you want your electricians to be working on a single panel at a time. So that way you can turn on this panel and then be working to get it communicating. Now, the way these systems are working, like this system, has to have communication back to, the PLC is eventually going to be in this room, but right now the PLC is in a little box right here. And so I have this little box, you can't really see it, but it has a little 24-volt power supply in it, and I have my main PLC just sitting in a little box. And then that way I can plug this cable right here, is plugged directly into my PLC. Now, the topology and kind of some of the more advanced functions, you're not going to be able to set, because, hey, this is always going to be complaining that in the main system, this is not going to be directly connected to the PLC. So when you set your topology in your project, this isn't going to be right. So I've got my PLC in a little box with a 24-volt power supply. But also, one thing that you have to bring yourself, okay, is, you can't see it, but is, I guess you can't, a really good extension cord, okay? And what I mean by really good extension cord, this is I think it's a 14 gauge multi-stranded extension cord. And that way, and it has 3 outlets on the end of it. You always want, like, if you're going to spend money on some of these things, having a good extension cord, having a good set of gloves that are comfortable, that are for you, having a chair that is comfortable, having a desk that is comfortable, these sorts of things will make your experience so much better. So I've got this extension cord that I can pretty much move around anywhere in this room. The last little thing in my kit is a 100-foot long Ethernet cable. I know I told you that I also carry around a box of these guys. These are, I think these are 2 meter cables, so 6 feet. I've got a box of 10 of these that if I need something, I can string together stuff, because you'll be surprised at how much just a 2 or 3 meter Ethernet cable, how much time it can save you just by having some of these. Because my 100-foot is stretching all the way down to kind of midway to this room and connecting into the only port that has fiber optic cable going to the main PLC, or the main IT cabinet. So the only reason I'm able to do this stream is because of that connection to that port down there. So have a really long Ethernet cable and then a bunch of these smaller Ethernet cables. You'll be surprised how much it saves you. So like here, you can see I'm using like a little 6-foot long cable to plug my processor into this switch. Well, it could be that, oh, hey, for some reason, this connector here doesn't work, and it's the first connector going to my drives, which are daisy chained together. For some reason, that thing's bad, and I don't have my crimpers or whatever. They're doing something else. They can't get to it. So you just grab one of these out of your van and plug it in and get to work. So the first thing that you're going to go through is, in these cases, we have these little remote racks, and you want to get your remote racks programmed. And I'm going to show you. I can't show you like live how to do this because unfortunately, the network situation here, I have to use my network cable in order to connect to the internet, in order to stream. But what you're going to do is use a tool called Accessible Devices. So let's hop over and see if we can get onto Portal. And I'm going to have to redo this stupid thing again. So let me try this again. OBS. And hopefully it works. Yep. So we've got this screen cap here. Let's change this over to Portal. And this guy. And swap that. That is messed up. So let's fix this real quick. That is working. Come on. We'll get it here in a second. Trying to get it to where you can actually see everything. All right. Man. You can do it. There. And then thank you for your patience on all of the weird stuff that I'm having to put up with. Oh yeah, I forgot I had this little dead zone down at the bottom. Alright, so let's look at our portal now. Hopefully you can still see me. I'm having to do all this on one screen, so I'm not really used to it. Normally I have 4 screens, so this is a little different. So what we would normally do is use a tool called Online Access. And again, I'm not going to be able to do it, unfortunately, because I'm streaming, and so I'm using my Ethernet port for that. And frankly, I don't actually, yeah, I don't have the ability to. I guess I would, but anyway. So we would use this Ethernet and say update accessible devices. Now, one of the things that you're going to have to do, though, is when you update the accessible devices on stuff that has not been set up first, you are going to have to, it's just going to show MAC addresses and type. I wish that I would be able to, yeah, my IP address is just messed up. I know a way that it would do it, but so we would double click update accessible devices, and it's not going to show anything here, or at least I hope it doesn't. But you would be able to right click on that device. Actually, there'd be a little drop down thing like this, and then go to online access, online and diagnostics, sorry. And you would be able to, I've shown this in a couple of other things. So in my portal for beginners video, it actually goes through this process of seeing online access, going into the configuration for that. And yeah, so what you're going to be doing is, let me show you my devices and networks for this system, because it makes a little bit more sense when you make your device and networks. So for example, again, I tell you over and over and over again, if you want to save a ton of time when you're starting up a system, name your devices in that system name them appropriately. You don't have to use this type of naming scheme, but the way that I do these sorts of systems is I have the device type is the first two letters. So this is a switch, a network switch. So it's SW. This is a remote rack. So an ET200 remote rack interface. So I put RR for a remote rack. You could do something else. A drive, DR. And then if for devices that have that are in different panels, that could be in a different, so a drive is always going to be in one of these panels like this. So I call these control panels. So like motor control panels, MCPs. So that's what we call these guys. Out in the field, we call those automation panels. And so those are called APs. So inside my program, if this device can be in either one of those, I need to be able to delineate between them. And so that's the difference here between the A and the C. So I can immediately tell this device is in an automation panel out in the field if this has an A. So remote rack A, switch A. I can immediately tell that that's in a little panel. I can immediately tell this switch is in a big panel because it has a C for controls, automation controls. That's what this is. Just those little things will save you light years of time. So what I have gone through and done is if you click this little guy here, it will eventually show the IP addresses. This is a big project. It's even bigger now. And I clicked it twice. So it will show all of these IP addresses. And again, these are all private IP addresses, but you can see there are a lot of them. I have almost used an entirety of a subnet. I say that, like 170 devices. Kind of crazy. But if you notice, this is a lot to commission. Each one of these drives, if you're not efficient with this process, it is going to take you a long time. I say you. It would take me or Terrence. Shout out to Terrence, my new startup guy. So yeah, I got a question here on about the server module at the end of the I/O module. And if you want to have a bad day, you will open up. Actually, I kind of want to go run because I have one of these out in my van. No, never mind. It's not out in my van. It's out. Yeah, I do. So when you open up an ET200 SP, like an IM155-6, you'll have the actual IM155, and then you'll have this little piece of plastic, and it's like this little thing. Hold on. Let me just go get one because I want to show you. Because break time. Let me run out here to my van and be right back. All right. By the way, fan's right outside the door. This place is big. Did I tell you that? Yeah. Sorry for your ears. Hold on. Let me mute this because I'm sure that's loud. All right. So I got Ahmad here is asking about the server module, and so let's take, this is a ET200 interface module, like that. And I'm just going to open this guy up. Okay. And you sit here, and I'll show you this. I can't pull it up full screen, but I take and I'm like, okay, I open this up, and it looks like this, and I'm holding on this side a piece of plastic. All right, and so you're like, oh, my nice little device. All right, that's nice and cool. Let's see if I get that. Open this up, and you're like, all right, this is what I want, right? That's what I want. I like this. That's my ET200 module. You're like, that's what I want. What's this thing? Whatever. Throw it away. You're about to have a bad time. Because this little guy right here is what Ahmed's referring to as the server module. Okay? This little guy actually tells your rack that this rack is complete. So this server module is always on the end of an ET200 rack. So if you toss this out, this is worthless. So you can't use this without this. These are paired together. That's why they come together. And so when you stack up let's do it backwards. When you stack up your rack, kind of goes out this way, like that, out like that. You always are going to put this. It's got the little button on the top, like that, on the end of that rack. So as it gets built up, you're adding them in. You put this on to the end. That tells the system that this rack is complete. It has some resistors and stuff terminating in the end, and this says, hey, this rack is complete. And you can see it finishes up the module. And so it clicks in just the same as an ET200 part, like that. So you always have to use this. So don't let your people throw these away because you can't use the ET200 rack. So that's why we are using the server module at the end of an IO rack, because this tells you that rack is complete. And so there's a lot of things that you'll do when you first pull up a device. That may be something you might not have your server module on it. And so when we go into, I'll pull up to a portal here. Let's just go into this system behind me is zone 100. So this is actually receiving. Let's go into the device view. Put this up. Man, how long have we been going? I feel like we've been going for a while. Oh, almost 2 hours. Again, I wish I could. There's no way for me, there's no Wi-Fi here. So I can't be on the internet and be on my system because they are two totally separate systems, as they should be. But you can see here, this little server module has to be there. And it has to be in the rack in order to finish it off. So what'll happen is it will show that this isn't there, but it will also sometimes show that this isn't there. And you're sitting there like, of course it's there. What's going on? Well, it just doesn't know that it's not there. That communication bus has not been terminated. And so you don't have communication going back and forth. So some really weird stuff will happen here. So again, I wish I could show it to you, but one thing that will go on if across the top of your system, let me make sure that give you a little bit of an angle. So across the top of this system here, the lights that are going to be on this, if you are communicating, it's going to look like this. So this is what you're going for. So like I don't know if you could see it on there, but all the lights are solid green. There's a row of lights that are green across the top, and then there's a row of lights that are green that are across the bottom. Okay, so all the lights are green and they are solid. So what will happen if something is not configured correctly or is not in the project, that will be flashing. Okay, so it'll be a green light, but it'll be flashing. If there's a problem, which I'll show you a communication problem here in a second, but if there's a problem, then you're not going to be solid. Let me do a full screen and see if you can. Let me fix it again. I don't know why it does this, but whatever. So yeah, you can see a little bit there. So it's a little bit better. But you can see the flashing lights there are from that Ethernet switch, and the lights across the top, you can see those are solid. Now I'm going to unplug this from the PLC, and they will start to flash. Hopefully you can see it. Okay, so let's see. Can you see the one that's flashing? Yeah. So the ET200 module itself has a light on it, and this is, you can see that all of the lights across the top of here, all of these lights across the top of here are still solid green, because that means that they are configured in the program of this little guy here. So in our ET200, all right, I'll show you this. Our ET200 has a couple little LEDs right at the top there. They're very small, and you can barely see that one is flashing in the video, but it is this first little green light, the run. Okay, and so that one is flashing green. What will happen is, if there is not configured, everything in that rack will be flashing green. Okay, and there's an error, which is a red, which is on here. If there's a problem with a device, it will flash red. Maybe I'll show you that. See if I can show you an example of that here in a second by like pulling a module. So that's saying it doesn't have communication. It is set up correctly, but it doesn't have communication. So how do we get everything set up correctly? So I plug this back in, and it's back solid. So that shows you that communication is good to the processor. So let's go back to Portal real quick, and I'm going to show you a couple of little things. I need to actually shift it over to Portal and reset my camera again. Okay, so we're still here. I'm going to make myself a little bit. No, that's fine. So we're here in this window. Actually, let's go to network view. Okay, so for zone 100, if I were online, you have to have the PLC downloaded with this whole configuration. So everything up there on the screen has to be downloaded onto the PLC. And again, I wish that there was Wi-Fi here, but there's not, because I can't be online and connected to the processor at the same time, and I apologize for that. But what we would do is, the first thing is we'd go up to the processor, click on it, and click download. And it would go through and compile all of the configuration. It would go through everything. And obviously, I was connected to this before, And so it's a little confused at why it can't see the PLC, because Portal keeps up with the fact that, like, oh, hey, this is how I connected before. This should be fine. And oh, hey, I have this Ethernet connection here. I have this. So why am I not seeing my device? And so that's when it pulls up this. Well, I have in here, in my compiled program, I have the PLC that for 11.10. So it has the subnet and IP addresses for everything for this. So what I would do is I would go through and say, show devices with these same addresses and start search. I'm not going to do that now because it's not connected. It's not going to find anything. I don't want to jam up this. So if you say show devices with the same address, then it's expecting you to obviously have the IP address set up. If this is the first time you're downloading to your PLC, which honestly is kind of the first thing that you want to do is have the program downloaded to this, you would say show all compatible devices. Would go out there, see any 1500 PLC that it could see, and then it would tell you, all right, here's what we're using. So it would see it and you'd click load. We're going to click cancel and get out of it. So once you have that downloaded, the PLC knows, hey, I am trying to look for a remote rack at IP address 11.26 in this case, and that has a Profinet address name called remote rack CZ100. And again, name your stuff well. It will save you so much trouble. And here's why. Over here, remember we talked about the accessible devices that we have? When you go and do the online diagnostics with this tool, you can go to set Profinet address name, okay? And you can type in that Profinet address name and change the device. Now, in this case, if this was the only thing connected up to this device, I would know, hey, this is the only ET200 remote rack that I have. Well, what happens if all of these panels have their remote racks connected and I can see all of them? Well, it'll show up in this accessible devices. So it will show up there. But what we want is to know which one is that. There's two ways of going about that. First of all, I don't have the server. No, I do. It is here. So on the front of this little rack, all right, the MAC address, hard to see, but I promise you, the MAC address is written right above the power terminals. So on most of these devices, there's going to be the MAC address written on it. So you can go in, and if this was unconfigured and it doesn't have a Profinet name or an IP address, nothing is going to happen. It's just going to show up in accessible devices as an ET200 like head unit. So you're going to look for that MAC address, and you're going to go online at diagnostics in this tool here. You're going to go on with the device that has that MAC address. And so you know that's that MAC address. Okay, that's pretty simple. Cool thing is you know that MAC address, you know you're on the right one. Go to the assigned Profinet name, and if you assign the Profinet name exactly the same, so in this case it's not case sensitive, so you can just type RR-C-Z100 and it will, and then say assign name. Down at the bottom in the little info tab, you'll see a little thing that says down here, it says Profinet device name assigned correctly or successfully. Okay. Well, you're like, now I have to go set my IP address, right? Not exactly. Because you have downloaded to the PLC first, it knows I need to be communicating to a remote rack that has the name RRCZ100, and that IP address is 26. Okay? Well, we go and look. I'll show you. There is, I think it's synchronized router settings with the I/O controller. If you have that checkbox checked, when it sees a device called RR-C-Z100, it will automatically, the PLC will set the IP address for this automatically in order to make it work. So what will happen is immediately when you change this Profinet address name, all of a sudden you will get a green light on this device. Now, all the others might not be correct. What normally happens is some of your modules will all of a sudden be solid green, and most of them will be solid green, and that's showing, hey, I'm configured correctly, I match what is in the project, I have no problem. And so that's what you're trying to get, and that's what we have up here right now. And so it's communicating, it's configured. Well, what happens if for some reason you have one module that is flashing green still? What does that mean? Well, you'll go into the device view, and if you're online, there will be not a solid red block here. There will be a green block with a little red exclamation mark. And you'll go through, and the flashing module will most likely have a little whitish, bluish symbol, and if you hover over it, it'll say device not found. Well, usually what that means is the device that is in the actual program is not the device that's actually plugged into the module. In my case, I went through on a lot of these. They came out when I first built this project back a long time ago when I was building out the hardware so we could do the drawings for it. They had a different module, different set of modules available. And I standardized later on a larger module that could fit more of my motors so I could have common spares. And so a lot of those older modules I've replaced with this newer number. And so I never updated those in the project. So what happens is I have to go in, and you have to modify hardware with everything offline. So the easiest way is to click here above at the top of this project, like at your project tree, and then click Go Offline and select everything. And then just say Go Offline. And then you will be able to change, right-click, change device, and then change the device to the device that is actually in the field. So you're going through each one of these and you're trying to get all green lights on everything, right? And so just take it one step at a time. Take it at the same pace all the time. Work on an ET200 module to get all green lights. Make sure that everything that is actually in the field is exactly the same as in the project. And in my case, most of the time, if there's a difference, I'm going to change my project to what is in the field. Most of the time, my guys have followed the correct list, but sometimes it's like, oh, I don't have enough modules in my project, or I have too many modules. We pulled one out whenever. So just be sure that when you are going through and going through all of this, that you're just taking it systematically, going through and taking that step. Now, the biggest thing I could say is when you're going through, originally set this Ethernet address, always synchronize router settings with the I/O controller, because it's really easy to keep up with all of your IP addresses here. First of all, it'll tell you if you have duplicates. And then second, you could sit and you could just see as you're going through all of your IP addresses. Then use your online tools and then update accessible devices and find the IP address, not the IP address, the MAC address of the device you're looking for. Now, the second way that you can identify what device you are online with in this online access is because one thing, these drives here, they do not have their MAC address written on them on the front, so they're kind of hard to see. I think they're actually written on the back side of these control units for some reason. I don't know. But the MAC address is hard to see on these. So what you can do is when you go to assign Profinet address name, there's a little checkbox that says LED flashes. Okay? Check that box, and on this device, you see where this is. Can y'all see me? I gotta make sure that y'all can see me. I don't think you can see it from this little mini, but the top light on this device here is flashing red because it has a Profibus timeout fault on it right now. When you check that LED flashes, that top light will start flashing off and orange. So it'll be orange off, and it'll be flashing like that. At, I think it's 1 hertz, so it's just a slow flashing. Do that, visually see, okay, this is the device that I am looking for. It matches, down here, you can't really see it, this has a name on my drawings, because I didn't talk to you about this before, but you need to have your drawings at this point, because you have to match the drawings, because your electricians are using these drawings to match what is in the field. So this is how they're going to wire them up. And so in these, there is a name for like the baghouse filter, whatever. And in them, you have, okay, this is on 200, so this isn't for this panel, this is for the one right next to it. But this motor is what my name in Portal is going to be. So, for example, this drive is actually, these are for zone 200. So 200-010, so 010. This guy right here is going to be, it's going to be drive 15G. And so if I look back here, it is not in this panel, it's in the other panel, of course. But it is a 7.5 horsepower drive. It is a 7.5 horsepower motor. It has the part number of the drive on it. And so I'm verifying what the drawings, because this is how these panels were built, I'm verifying what the drawings say to what is in my program up there. So I go through that and I see that, all right, this number, this one is VFD 13N. So I go to, that should be, oh. Of course, these aren't going to be in this panel because this is the wrong panel. But I would go to VFD 13N1. And so I would go to page 13N, and then it's the only drive on that panel, or on that page. And I would see whatever that is. And I would verify that that is the correct device that I'm trying to download to. And so I would then take whatever name I have done for that device, say that is DR100-040-001 here, I would go change the Profinet name to DR-100-040-001. And the moment I change that, the PLC would say, oh, hey, I've got my 040 001 drive is communicating now. Oh, it doesn't have its IP address. It needs to be 120 because I have that synchronized with the IP address or synchronized with IO controller. So that's, as you step through, that is your first thing that you are wanting to do. Now, what with the drives, so it's pretty straightforward. You have downloaded the PLC contains all of the program information for the ET200, okay? The PLC does not contain the program for these drives. So when you're doing a drive, the first thing you want to do is download. So click on it and then click download. So once you know you can communicate to it because you've seen it in online access. And so one little trick to know that your IP address gets set correctly, when you click update accessible devices and you double click on it and it updates it, if it is showing just a MAC address, that is an unconfigured device. If it is showing just a Profinet name and it has a MAC address, then that means the IP address hasn't been set. And so your Profinet name is probably not the same as what the Profinet name in the program is. So check that, because when you click Update Accessible Devices and you have a fully configured device, what it comes up with is the name and the IP address. So a fully configured device comes up with the Profinet name that is configured and the IP address. If it doesn't have both of those, something is not configured correctly. So because you have now DR100 040-001 and it shows up in your accessible devices as IP address 120 here, you know that you can communicate to it. You know that it's set on the right thing. So what you would do is you would click download and it would pull up the same thing. Let's just pull this up. It's going to take a second. Take a little sip. This is your first time joining. I haven't said it in a minute. Be sure to click like on this and check out the rest of the channel. Check out all of the other videos we have. We try to do live stream once a week, and I have a bunch of edited content. I'm going to try to get back on. My wife does the editing for me, but I haven't given her any material to edit so far. So hopefully we'll be getting more edited videos back up here soon. But yeah, lots of training videos for Siemens industrial automation experience. My name is Jason Watts. I've got about 24 years or so of experience, 23, 24 years of experience with Siemens automation equipment. So I love it. And so yeah, back to this program. If all of this stuff you like, maybe consider subscribing. So now that we know that our device is configured correctly, when we pull up this extended download to device, when we pull up this download, we know that if we click show devices with the same address, we know that it is only going to show up the device that we actually want to download to. So it would show up in this, we would click load, and it would kind of spin for a second, and then it would say, hey, do you want to save device to the copy RAM to ROM? Definitely check that device, because what you're doing is you are saving the Profinet communication. Once it does that download and starts back up, guess what? Your light should be green here because you will be in Profinet communication at that point, because when you do that download, it will download this Telegram configuration that you have here. And because you are using Portal, when you had this Telegram configured, when you did the download to the PLC, it automatically set up that Telegram configuration for it to be sitting there waiting for that drive. So it already has all the IO, it already has all of that. So once you download to the drive says, oh, hey, I need to be sending out a Siemens 352 telegram. Cool. And I'm going to be responding at this address. It's going to be communicating. So this will come up with a all green. So what you will see is if your drive is not, if your drive is communicating, but it is not, it's not being commanded to be on, what you will see is this top light will be flashing green, a slow flashing green. Once you go into actual cyclic control, that will stop flashing green. That will be solid green, and it will be ready to go. Okay, so that's your drives, and that gets it to where you have downloaded your drive. It is sitting there ready. Most of the time, you have gone through, and at this point, you haven't really necessarily done any of the motor configuration on it. You don't have to have done that portion of it yet. You're just getting communication. You can get your telegrams hooked up, and I've shown you before about how I use my blocks in here, and I may get to it here in a second. We're already at 2 hours on this stream, and so I'm probably going to go for another 20 minutes or so as talking about this, so we're trying to get as much into it. So I haven't put in any motor data because really at this point, I probably don't even have a motor hooked up. So on these, they are hooked up. I've been able to wait long enough to where these motors are hooked up. And after the stream, I'm actually going to be hooking up and doing motor IDs and everything. But most likely, when you're trying to get all green lights on the system, you're not going to have a motor hooked up. And so there's no point in even really putting motor data in because they may change the motor. It might be something different. Like that's going to be a different process. You're trying to keep momentum on your commissioning. In a project like this, the biggest thing is keeping momentum on commissioning. If you can get all green lights, if you can get to where you can download to everything in this panel, that is a monumental achievement in a commissioning state of this large. So I mentioned my new commissioning guy earlier. He went through and did this like step by step, every panel. He went around with this PLC and just got green lights on all the panels he could. But there's obviously going to be some that he didn't have access to. Like this panel didn't have power fed to it. They were working on it while he was here. And so he couldn't do it. So I came through, and that's the monumental thing that I was trying to do, was get everything communicating. And if you can get an entire panel set up and ready to tune a motor or to bump a motor, check rotation, that is an incredible feat, because that is going to save you so much time later on. So I don't have them right now because I've got to reset this fault, but everything in this panel is ready to go. So what I'm going to be doing later, and what you would do next, is once the motors get hooked up to these, I am going to put in a protocol around startup protocol. Okay? And we're going to shift away a little bit from Portal. Actually, I'm going to finish up talking about Portal. I'm going to show you how I step through my logic on this and how I use my function blocks to be able to communicate to these drives and communicate to these starters, so that maybe you can take a little bit of that information and put it to it. Then we'll talk about next steps in commissioning. So let's go here real quick to the actual program for this. One thing that in a project this big, I cannot emphasize enough is organize your project properly. Portal has this amazing tool called groups. And so I can go and right click and say add new group, and I can sort data blocks, function calls, function blocks. I can sort them around. So all of this equipment that we ran over in all of the videos at the beginning of this stream, I have to separate out into zones. And so each zone control, each zone has its own FC that gets put into main. So OB1 is the cyclic communication block that is just your main program cycle. And for me, essentially, it will just be filled with these. There'll be a safety call, there'll be zone calls, and that's basically it. Everything else is going to be in some sort of function call. And so inside these function calls, I actually have my function blocks for each of my equipment. So I organize these, and I have it done. I could show you this real quick. So these are all because I have named these blocks. So this is 150-112. So let's open up real quick. I'll show you what this is. When I pull in one of these function blocks, it asks me, so for this AG 352 drive control, it asks for an instance data block. I named this one 150-020-001 control. And that tells me I name all of these blocks. If it says control, that means it is an instance data block for that data, for that equipment number. So that is the designation in the plant, that 150-20-001. There's a metal placard on that piece of equipment out there. It's actually in between the buildings. It's the outside equipment that I showed you in that video. That is the pre-dryer storage bin feeder screw. So that I don't know where that physically would be, but that is what that is named. So if that is control, you can see that it's right here. That is an instance data block. So anything that says equipment number control, I know is going to be an equipment instance data block. And so I have a group for it. And so what I'm going to do is I'm going to take all of these, and I'm always going to just drag them into this equipment IDB group. So that way, if I'm navigating through something, I don't have to scroll and find. Later on, I'll be doing something like with, say, a faceplate, for example, and I'm wanting to drag in some data from these equipment IDBs, because the way I organize these data blocks, or these function blocks, I should say, is I have a standard set of information that if I'm controlling a drive or I'm controlling a starter, it has these standard set of controls. So all of these are drives because I was messing with trying to get all the drives done. I'm not actually bumping motors at this point. And so if I want to access any of these data blocks, I can just click here and I have a details window. I have access that I can like drag and drop stuff out of these blocks. So say if I wanted this, so say I wanted, this is actually something that I would do. So if this drag conveyor, for example, has to be on for these drive screws to be on, I might take, so this is 150-170. I come down here, I find 150-170 control, and I know that I have a bit called sequence ready. And it is in, there it is, right there. And so I would make sure to put this like this. And that would, if that sequence is ready, it would give the ability to start that module. So that is I'm only able to do that quickly because I have named the equipment the way I have named it, okay? And then using these groups makes it to where I can find those things really quickly. So I'm going to delete this because eventually I will want to do that, but not right now. So I'll show you the next thing that you have to do with drives. If you are commissioning a drive, you need to make a tag that associates your hardware ID, or I guess your input and output addresses, to your the actual drive itself. And where that is found is if you click on this device, these I/O addresses are found in Telegram configuration, and I'm going to pull this over. It's these partner data areas, okay? And so what I will do is I will actually make a tag table called drive telegrams. And for that device, so this is drive 140 100 or 001. So it should be up at the very top. And I will make a drive 100 040 001 tel in and tel out. So that's what we have here. Now, I have gone through and made a custom data type called ag drive tel in 350 or ag drive tel 352 in and ag drive tel 352 out, because I actually use a little bit of the user data that's available to you in Telegram 352 in order to do torque control. And I've talked about this in the load sharing labs. So check those out if you haven't. If you don't know what I'm talking about, check out the load sharing stream. You'll see what these data types are. I'm not going to go into them now, but I've made these data types to where I make the tag name, the drive name, tel in, drive name, tel out, and then I assign the input address. So I554.0, I'm going to I554.0, and then Q256.0. Go back here and you'll see it, Q256.0. Cool, right? So what I do at that point is I tie those telegrams to my block. And inside my block, it actually has the configuration to where it will enable the bit 10 controlled by PLC. It automatically locks that in. So I drag in from my utility FCs and FBs, I would drag in a drive 352 drive control. Oops. Drag it in like this. It asks me for a data block name. I'm going to cancel so I don't mess up this program. And so this would normally have the data block name, and it would make the data block for me. And then I would go and take from my, I would say drive dash 100 dash 040 001 tel in, right? What? It went red. Why? It's saying unexpected input. Oh, there's a period here. So when I click enter, you have to click on the none. And so you have to hit enter 3 times in order to get that actually in. So then I would go drive 100-040-100 tel out, enter, enter. Okay, so tel out. And now when I download this onto my processor, that processor is going to actually start sending that data back and forth. And one of the cool things, I'm going to delete this. One of the cool things is in our online and diagnostics, if I were to go here, right click here, and go to online and diagnostics, there is a tab on here called control and status words. And you can look straight from there without pulling up anything else. You click here, go online with the device, look at the control and status words, and you will see, if you're using my block, you will see that that bit 10 has turned on and you have this information that's being passed back and forth. So that way, I know that that green light, I know this is red, but that green light that's on that drive, I have full communication and full control by my PLC. So at that point, I am ready to actually turn on a motor from my PLC. Cool. So that is getting ready to the next step, getting ready to where you will actually start moving equipment. Okay? And so at that point, I would just go through and set up like I've done here, configure, bring in all of my blocks, bring in all of my telegrams, and you can see that some of these are different. So I'll talk about my starter control. For some reason, because that one's not there. That one's not there. So I guess I haven't tied them in. Okay, here's one that's actually there. So I went and had all of this data there, and then it turns out that, oh, hey, they're not actually connected out in the field. So here is the block for one of these remote ET200 racks. So the ET200 remote rack starters. Um, in my block, I'm doing a little bit of read record, data record transfers. So I'm getting the current value using a data record. And so inside my block, I need the hardware ID. And so again, I named my devices properly. So I can go through and type remote rack-C, so RR-C-Z100, and then it'll pull up and I'll say, okay, I can find my 100-100, and then that is the hardware ID, and it just shows up so nice. And it's all because in my remote rack, so this Z100 remote rack, we'll go to device view, I named this thing properly. So remote rack-C-Z100 tilde 100-100, and that's the hardware ID that is in my device right here, and it populates that hardware ID for you. Otherwise, you would actually have to go into the device, click on the device, go to I/O addresses, maybe. No, where is it? I'll see. It's I always forget this. It's under System Constants. So you click on the device, go to System Constants, and you're there. I haven't checked. I'm sorry, I haven't been paying attention to chat. I've just been kind of talking. Um, so why server module? Do I come with server module? So I'm checking up on chat. Sorry, I had the screen open. My bad. I've been ignoring you, chat. Uh, so a couple of questions about these. So server modules. Um, so server module, like we talked about, is termination for the end of these. So that's what that is doing. That is ending your remote rack. Any ET200 device, so not just the IM151, you have like the PLC device as well, will have a server rack. So any head unit that controls a ET200 is going to have a the server module built into it. So if you have a third-party device like a Festo, that's going to be built into the GSD file of what it needs. If you we don't assign device name and try to set IP address in third-party device, it doesn't get healthy into assigned device name. So we were talking about the device name. So a little bit about Profinet communication is the fact that Profinet is technically device name first, then IP address. So the way Profinet works is built into the TCP stack. There's kind of a little Profinet channel, and it's kind of a bypass, and it's that Profinet name. So the way that it can go have better communication and quicker communication and not get bogged down by regular IP, it uses a Profinet device name. And so all of the devices that are sitting there on a Profinet device, they're sending that Profinet device name. If you don't have it, then it's just null. It's just not there. And so like your Linksys router from Walmart, it doesn't have a Profinet device name, but it is forwarding these Profinet packets because it's built into the TCP stack. So with the third-party devices, they are absolutely 100% Profinet devices. So you have to set the Profinet name, and because you haven't set there's no way to that little checkbox in the hardware configuration. There's no checkbox. You're going to have to set both the IP address and the Profinet name before Profinet communication can start working together, because your routers and everything won't be forwarding that subnet information. It's not going to be forwarding that information. So just to reiterate, kind of wrap it all up, Profinet, you have to have the device name set in order to communicate on Profinet. The way that we've done it for this one, for our system, is absolutely because we were able to check that little checkbox that said synchronize with the I/O controller. If we set our device name, the PLC goes ahead and says, "Oh, hey, I see that because Profinet's. I'm already communicating because I'm really looking at Profinet name first, then IP address, then MAC address. Those are the three ways that Profinet order of levels. So when it sees that Profinet name, it says, oh, hey, that's supposed to be IP address 128, whatever. And so it goes ahead and sets it. So, and Mika, welcome to our membership. We have a new member. Mika has been added to at the programmer level. And again, normally on stream, those programmer levels will be getting the projects that we work on stream. Obviously, I can't give you this project. This is a bit too much. This is a customer project, but I will be doing some projects later on with some blocks, and I am going to be doing some data blocks that we talked about last week, like a heart control block. I'll be building that next week on stream or maybe off stream, depending on what we're doing. But welcome to memberships, Mika. And again, I'm sorry for losing track of kind of the chat, but we'll get back onto it. So I'm going to switch back over talking about, so now that we have done inside of Portal, we have done this, what's it called, the blocks. We have seen that our drives actually are communicating. We have control over our blocks. We can actually go through, and I'm going to bring up because we're going to go full screen here. Do this again. I don't know why. Love it. And so the rest of the time that we have, we're probably going to go for another 10 or 15 minutes. I want to talk about the process that you need to go through and set in controls once you start bumping motors. So on this project specifically, obviously this room is really far away from where this panel is probably a good 300 feet. So it's 100 meters, 200 meters, or 150 meters away from where this equipment actually is. Obviously, I can't see this equipment, okay? So one of the reasons why I wanted to be out here when nobody was here is so that I can sit there, walk out, make sure that everything is going to be able to be looked at appropriately, and I have control. I'm going to be walking back and forth in all of these motors in this Zone 100 panel and tuning these motors. Now, I'm not going to actually turn any of these motors. I'm just going to do the stationary ID, just making sure that all of my motors are actually hooked up to what they are supposed to be hooked up to. Because there's a couple of different things that can go on when you are first starting up a system like this. The first is going to be that your motor is actually hooked up to the wrong piece of equipment. So your drive in here is physically wired to the wrong thing in the out in the field, and it happens all the time. Because honestly, if you've noticed, I have a lot of equipment numbers that are like the first one, for example, is 100-40-001 and then 002. That's two screws that are on one feeder. So you have one hopper and you have two screws that are going to be running off of that same hopper. So it's called a dual screw feeder. Well, those might just be swapped. So your nameplate has to match the drive. That's kind of a legal thing, because if you go out there and you disconnect that screw, obviously, and you lock out and tag out, then you switch that lockout and tag out. You have to be able to see the disconnect from where you were working from. So where that motor actually is, you have to be able to physically see that disconnect. And then that is where you put your lock on. Now, when a system is in startup like this, it is very, very dangerous with so many people all over the place. So there's probably 150 people out here at any given time working on this equipment. And it just takes one person that is a construction guy that's sitting there working on something to just go, oh, hey, I need to go over here and check to see how this thing is wired up. And he walks over and is poking or looking at some sort of belt, and just so happens to be that's the one that you're turning and you're bumping. But that construction worker has been working for a year and a half on this plant, and it's not in his mind that that piece of equipment can come on. So there's two things that you have to do when you get into this kind of like startup stage. First, you want to work with your, in this case, millwrights, to where their managers, their foremen, prohibit working on equipment in an area to where you are going to be working. And that foreman has to be the one that has the radio that is communicating to me that that equipment is safe to bump. So I don't have my radio with me right now because, I mean, I'm not going to be moving anything. But that foreman who has the authority to stop work in that area has to be the one that is responsible for keeping his guys and keeping people out of that equipment. And because there's hundreds of people out here, they're crawling all over the place. You cannot have somebody that is just some dude that doesn't understand the magnitude, that's sitting there with a radio watching, and then your foreman comes up and says, hey, I need you to go over this, and he says, okay, boss, and then walks off, and then you have an intern or like a guy pulling out equipment and then gets his hand cut off because of a chain on a piece of equipment. So you have to have people that have the authority to make decisions, to be the one taking responsibility for the equipment. Now, that's me, and that's that foreman out there. And so that I can't stress that enough. And as a person that, I guess, so if I mess something up because I'm the owner of this company, yes, my company has insurance, my company is an LLC. And so if we get sued, my company is getting sued. And so that is ultimately going to come back on me. If I kill someone because of something that my company is doing, then it's actually in the US, it's going to be coming back onto me. Even if that's not the case of like kind of in other places, like the company is going to be liable for anything that happens. So, with that said, I am distinctly motivated to keep everything like proper. Not just because like you literally have people's lives in your hands when you're doing this. So this is extremely important that you, the commissioning engineer, don't make a decision that costs someone their life. You want to know why commissioning engineers get paid so much? Is because they need to be so trusted that they will make the correct decision. And if a foreman on site, if a construction personnel or whatever cannot or will not give you the ability to do what I'm kind of these recommendations that I'm saying here, I recommend that you refuse to work at whatever consequence that means. If that means losing your job, if that means losing whatever, losing money, losing time, it is your responsibility to say, I am not going to be responsible for the danger that this can take. It takes half a second for someone to lose their life. And that really needs to get into your head when you are moving on to this sort of into these next stages. So with that in mind, I know that's kind of like doom and gloom, but you need to take pride. You need to take responsibility. You need to be the one that is the mature one. And I know it's hard, but if you have a foreman that's wanting you to do something that is unsafe, and more than just oh, hey, turn this breaker without gloves on. This sort of stuff, if you can't see it and you can't physically see the process, and you can't look in it and assure the safety of that equipment, and a foreman isn't going to do that for you, I recommend not working until that is possible at whatever cost. And sometimes those are decisions that are going to be difficult to make. Okay. And I understand, this is how you feed your family. This is how you provide for yourself. But at the same time, I promise you that foreman is going to pass the buck off onto you, because you're the one that is pressing the button that injured or killed someone. So just keep that in mind. Take responsibility for it. So once you have this safety protocol in place, to where you have someone that knows if they do not want a piece of equipment running, then they have to lock it out. They have to lock and tag out. In a construction environment, it is so much more difficult for that. In a regular production, once everything is running, there's a conversation that you give everyone a lock, and you tell them, if you do not want your hand to be disconnected from your wrist, if you do not want your arm to be disconnected from your body, if you do not want your life to be removed from your body, you put a lock on it. Because this system, and it sounds crazy, because obviously, as the program is not going to randomly start stuff up. It's not going to be a well-designed program is going to have levels of control in it that will prevent equipment just coming on and starting up. That's your job. But the people out in the field, the maintenance workers, the guys that will cost them the most with a mistake, they need to think that this is equipment will randomly start up. They need to be terrified of it. They need to not trust it. They need to not trust you. They need to, everything about it, they need to not trust. And that is going to keep you from getting in trouble. Because if they go out and put a lock on a piece of equipment that you're working on, because they're about to go over and look into it, and they leave that lock on and say, okay, and it causes you some sort of issue, you need to thank them. You need to absolutely thank them, because that is going to prevent a problem from you. So two different places during startup and commissioning, it is much more dangerous of an environment than during a regular production and once you've started it up. So during commissioning, have a person with authority, their eyes seeing whatever is going to be moving. And especially with motors, there can only be one disconnect on at any time when you are starting things up, until you have proven that your control controls that motor in the way that your proven control has been designed to control. There is only one, that only ever one disconnect switch can be on out in the field. And I know that sounds annoying, but again, right here today, there's all sorts of there's no one here, but that's going to prevent someone from getting hurt. So one disconnect. And so at that point, what you are going to do is you are going to turn on one disconnect, and then you are going to bump one motor. And that foreman, and in this case, the millwright, the job foreman for the millwright, he knows what direction it's supposed to be spinning. He knows, or she, they know that that the gearbox has motor or has oil in it, because these gearboxes don't have oil in it by default, and so that's a huge deal. So they know what the equipment is supposed to sound like, because some of this equipment is loud. Some of this equipment sounds like it is about to fling itself apart. And so you have to have someone with experience to know, oh, hey, this thing normally sounds like it's about to fly apart, or no, there is something wrong. Shut it off, shut it off, shut it off. So the first thing before you do any of that is you have to have an e-stop button that is proven to shut everything off with one press of a button. You cannot be fiddling around with a device or force table or anything like that. If you didn't notice in the videos, like the e-stop button, you see the little hole doesn't have the e-stop in it because it's on this panel. But all of these panels have an e-stop button. And so you have to have your hand over an e-stop button the first time you start a motor. Have it hovering over the e-stop. And that e-stop has to be proven ahead of time to be able to shut down all communication. So it's basically the last ditch thing. And when you click the button, you're sitting there on the radio, you have the radio, you're listening to it, because if he starts sitting there going, shut it off, shut it off, shut it off, shut it off, pop. You have to be able to hit it and stop immediately, okay? I know it sounds dramatic, but this is one of the differences between, I talk about it all the time, between programming in Python and with an Arduino. You might blow up an LED. You might, oh crap, I killed that 3-cent LED. Well, if you let something run for too long on some of these equipment, you could destroy $300,000, $400,000 worth of equipment. So, and again, that's if someone's not losing their life. But again, so verify that you have an e-stop that is absolutely going to work. And honestly, I normally have kind of like an e-stop, like push button little pendant station that I keep with me at my little station, and that's the system e-stop. I hit that e-stop and it's good. These panels all have e-stops on them, and so wherever I'm sitting, I can easily just have that e-stop just sitting right there. The only reason this panel is open right now is for a good backdrop. When I'm actually starting this stuff up, I'm not gonna have this panel open. I'm gonna have the e-stop, and I'm just gonna be able to sit there and slap it, and it'll cut it out. So that's the process of getting started. How do you manage what to do? So I talked about this before, is that the order of operations in getting one of these startups, getting one of these big remote I/O stations, get power, because if you have power, you can bring your little PLC in a box. You can at least get communication. You get green lights, or not communication. Power first, then Ethernet. Before anything, those are the first two things. Get power, then Ethernet. Don't wire a single motor. Don't wire a single I/O. Don't wire anything until you have power to every panel and Ethernet to every panel, okay? And obviously, there's going to be some exceptions to that. Like in this building, there's Ethernet runs that are too long that we're having to run fiber for. That's how big this building is. So there are more than 100 meters of Ethernet run. So all that to say, power and Ethernet first, then you're trying to get green lights on all your panels. But never, ever, ever assume that you don't have a short circuit in your power until you've proven otherwise, okay? So turn off all your breakers in everything, all your breakers in panels, and then you're working your way from breaker to breaker. And every one along the way, you're checking to just say, hey, do I have a dead short? Do I have a short to ground? Do I have a short to phase to phase? That's what you're checking. Once you get all of that, you can go through and start getting green lights. Again, you don't have to have full communication and everything to where it is. You can use a startup commissioning box and put your PLC in a little box and carry it to each panel. But you have to have the PLC in order to get the Profinet communication. Once you get your motors connected up to an entire panel, then you can start to contemplate whether or not you want to do a drive startup. Now, remember, just because you have your motors started up does not mean that your electricians are not wiring up I/O in a piece of equipment. So, again, that goes back to the stage, the idea of your production, or sorry, your foreman for your mechanical, so your construction foreman and your electrical foreman have to be the ones that have authority for people. So when we go to start this up, we might bump some motors later this week. In order to do that, I have my millwright foreman. He has the ability to fire anyone off of his crew. He has that ability. And then I have my electrical foreman who has the ability to fire anyone off of his crew. They are the ones that have the radios. They are going to be the ones that are responsible to, when I bump that one motor, they are the ones that say, okay, this is clear. This is clear. I can disconnect, or I can turn on this one disconnect for this one piece of equipment. And then when I tune that motor and I turn everything, they will know, okay, it is safe to turn, and then it is working properly. And then I can check that off and just continue down the line. Now, obviously for a project this big, that's a lot of work. That is a lot of work, but I promise you it's worth it. I promise you, if you do the homework ahead of time with proper naming of your equipment in your program, proper organization, proper use of function blocks. Do you want to know when I wrote that function block that I'm using in this program? I wrote it 3 years ago, 4 years ago. Yeah, 3.5 years ago, I wrote that block. I tested it. I know it works. I know all of the things in it. I know that it has been proven that it works. And so I lock it down. It's locked down. I use it, and that takes it off of me. And so for 150 motors that I have here, I know that I have control over it in a certain way. So do the work ahead of time to test out all those blocks. Verify those blocks. That's the only way that you're going to get through a project this big without significant heartache. So you can do it. We're here at Alpha. We are here on this channel. I say we. I am going to eventually talk some more about the ignition portion of it. I am going to talk more about the kind of SCADA platform, more of the integration of it. I'm going to get Brandon on here. I'm going to get him to teach me some basic ignition classes on here live. But that's going to be another time. Today we have been talking about Commissioning 101. And you're going to see more of this. I'm going to be more out here. I don't know if I'm going to be able to stream any more from here, because the only reason I was really able to stream today is because no one's here. So if you're in the U.S., have a great Memorial Day, and for all of those who've given their the ultimate sacrifice for this country and all these countries, we honor their sacrifice. And uh, as for everyone else that is here from abroad, thank you for taking part in this program. And yeah, if you're a member, thank you for the members. I see some light blue stars on here, so that means that you've been here for more than a month, and I can't appreciate you guys enough. Um, just having members gets these videos out. YouTube says, hey, this must be good content. This must be worth something, and it's getting it out there. And so you liking, commenting, all of those things and subscriptions go a long way for that algorithm as well, just to get us out there, because everybody on this channel, I believe, is really trying to find their way, and hopefully it is building you up for success in life and in your automation journey. So I'm going to get off right now and get back to working on some other stuff. And because we've been going for right at 3 hours. Somehow I thought this was going to be a shorter stream. Man, I, I never actually I never actually understand when it's going to be shorter or longer. But anyway, for all of you that have this is your first time on here, hopefully you would consider a subscription to this channel, because we do this try to do it every Monday, but hopefully around once every week, or at least 10 days, we try to do a live stream on here. But yeah, until we meet again, I hope you have uh, a great time in whatever you're working on. And oh, I haven't plugged the Discord. Made it this far and you're not on the Discord, check out the description for the Discord. We've got a great community over here in helping each other out. We've got a help desk. We've got just general automation chat, and uh, yeah. And I don't get time to play video games a lot, but I do have that channel set up to where if a group's playing some games, I know some of my friends, we will get on that group and play some Borderlands 2 and stuff like that together. And yeah, so we can enjoy our time off together too as well. But anyway, that's over on the Discord channel. Links in the description. But anyway, peace out. Y'all have a good rest of your week, and yeah, always be learning.